Okay, here we are in section 11.4, still involving logarithms. Recall last section, section 11.3, we introduced what a logarithms were. We defined it, okay? We talked about how we normally would have exponential form, where we have a base raised to a power and it equals a number. And then we said logarithmic form takes log base b of n and it equals that number p. And in both of these conditions, remember, certain conditions needed to be true in that your bases had to be a positive number, any positive number with the exception of the number 1, as well as n, okay, must also be a positive number. Those conditions must be true in order for us to talk about exponential form and logarithmic form. In section 11.4, we're going to talk about various properties of logarithms. Okay, these are statements that we know to be true, okay, and we can use them to do different things. One of our properties tells us that if we take the log base b of the same number b, that it will always equal a particular number, one number in particular, and that of course would be the number 1. So if I had, let's say, the log base 7 of 7, that would equal the number 1. If I had the log base 5 of 5, that would equal the number 1. Even if I had, let's say, the log base 1/3 of 1/3, that would also equal the number 1. Because if you think about this logarithmic property, writing it in exponential form, we would be able to say that the base to the power of 1 would have to equal the number b. Okay, so, and of course we know b to the first power equals b. So that would be our first property. A second property involving logarithms tells us that if we take the log, any base b of the number 1, that will always equal a particular number, and of course that number would be the number 0. So if I had, let's say, the log base 9 of 1, that would equal 0. If I had the log base 2 of the number 1, that would equal 0. Because if you think about your logarithmic expression, and if we were to put this logarithmic expression in exponential form, we would say that b to the 0 power equals, of course, the number 1. And we know that from when we talked about the laws of exponents. Some additional properties that we can use involving logarithms. For example, and these are properties that we are going to use to simplify. If we have the log base b of m, and if I am adding to it the log base b of the number n, well, as long as the base numbers are the same, and if we are adding these two logs, this can simplify to the log base b of the product of m times n. For example, if we had the log base 8 of 2, and if I was going to add to that the log base 8 of the number 5, that would equal the log base 8 of 2 times the 5, which of course would now give us 10. That would be your simplified expression. Okay, so we went from adding two logs that had the same base to one simplified expression. A fourth property tells us that the log base b of m, and if I am subtracting the log base b of n, that is going to equal the log base b of now m divided by n. Once again, we're looking to simplify and eliminate an operation, and we can eliminate the subtraction by dividing those numbers m and n. For example, if we had the log base 3 of, let's say, the number 16, and I was subtracting the log base 3 of the number 8, that is going to equal, now we can simplify and eliminate the subtraction, and that would give us the log base 3 of course, now 16 divided by 8, which of course would be the number 2. So that would be your simplified logarithmic expression. As long as the bases are the same, as we see in these examples, we can eliminate the addition and the subtraction of the logs by either multiplying or dividing those numbers of the log that you are taking of. We have, of course, a fifth property that involves multiplication. Addition becomes multiplication. Subtraction, we see, becomes division. But what if we have the log base b of a number, and let's say I am multiplying that by some unknown number. I'm going to give it the number p to represent that. Well, p times the log base b of m, that is going to equal the log base b of m to the p power. So you take m and you raise it to the power of p. So for example, if we had, let's say, 5 times the log base 7 of 2, and we want to eliminate this multiplication of 5 times, this would now become the log base 7. Well, if you take 2 and you raise it now to the 5th power, that would give you 32. So here we are using these properties to simplify your logarithmic expressions, if they're being added, subtracted, or if a logarithmic term is being multiplied with a number. Let's combine a few now, and let's actually incorporate some variables as well. Let's say we had the log base 9 of 2 plus the log base 9 of x minus the log base 9 of the variable y. Well, we want to simplify this expression. Whenever we simplify, we're looking to eliminate operations. And we have an operation of addition, and we have an operation of subtraction that we are looking to simplify. And since they all have the same base 9, we can use the properties listed above here. And let's start with the addition. The log base 9 of 2 plus the log base 9 of x, that would give us the log base 9 of 2 times x minus the log base 9 of y. So we eliminated the addition by multiplying the 2 with the x to give us the 2x. But now let's go and eliminate the subtraction of these common logs. And according to that fourth property listed above, this would now become the log base 9 of 2x divided by y, because subtraction becomes division. Let's try another one. Once again, we are looking to simplify. Let's say we have 4 times the log base 5 of x plus maybe 3 times the log base 5 of y. We want to simplify this logarithmic expression. Well, first let's eliminate the multiplication of 4 and the multiplication of 3. And according to that fifth property involving the logarithms, well, Numbers that are being multiplied with a logarithmic term become a power. So that would give us the log base 5 of x to the fourth plus the log base 5 of y cubed. So we eliminated the multiplication of 4 and the multiplication of 3 by turning them into powers. And now finally, we want to eliminate the addition of these two logs that have the same base. And according to that third property, we can eliminate addition through multiplication. And that would give us the log base 5 of x to the fourth times y to the third. And that would be your simplified, condensed logarithmic expression. We have eliminated all operations. We eliminated the multiplication, as well as we eliminated the addition. Sometimes we also want to expand, okay? We want to use those same properties and go in the reverse order of the simplifying. Sometimes we want to expand your logarithmic expression. For example, if we had the log base 2 of, let's say, 5x, and we want to expand that out, that would in fact become the log base 2 of 5 plus the log base 2 of x. Because the 5 and the x were being multiplied together, we were able to expand this out into the addition of two logarithmic terms. If I had, let's say, the log base 2 of maybe the fraction 3/5, we could expand that out as well. Because if things are being divided according to that fourth property, we would be able to write this as the log base 2 of 3 minus the log base 2 of 5. Because they were being divided, 3 divided by 5, we were able to expand that out into the subtraction of two different logarithmic terms. If I had, let's say, log base 5 of, let's say, x to the 6th power, and I want to expand that out, well, according to that fifth property, if there is a power, we can take that power and move it out in front and write it as 6 times the log base 5 of x. And that would be considered your expanded form, because instead of having just one simple log of x to the 6th, we have 6 times the log base 5 of x. So we can either simplify your logarithmic terms, or we can expand them out. Let's take a look at one more. Let's say we had the log base 6 of x squared y to the third divided by z to the fifth. And once again, we want to expand this logarithmic expression as much as possible. Well, if we were to expand this out, the first thing that I'm going to look to do is I'm going to expand out the division. So I'm going to write this as the log base 6 of x squared y cubed minus the log base 6 of z to the fifth. So that expands out the division and turned it into subtraction. Next, I want to expand out the multiplication. And we can do so, and that would give us the log base 6 of x squared plus the log base 6 of y cubed minus the log base 6 of z to the fifth. Now we expanded out the multiplication of the x squared y cubed, and we turned it into the addition of two logarithmic terms. Well, not only do we expand out the division, and not only do we expand out the multiplication, but we want to expand out the powers the power of 2, 3, and 5. And anytime we have a power, we know we can expand that out into the form of multiplication. So this first term would become 2 times the log base 6 of x, plus this second term would now become 3 times the log base 6 of the variable y. And then this third term would now become minus 5 times the log base 6 of z. And that would be your expanded logarithmic expression. So depending upon what you are asked to do, sometimes you are looking to simplify, which means you're looking to eliminate the adding and the subtracting as well as multiplication. Other times you will be asked to expand out your single logarithmic expression into the addition and subtraction of multiple logarithmic terms. So make sure you read the directions carefully. Okay? That completes section 11.4. Take a look at the homework. Give it a try. If you have any questions, feel free to email me. We have one more section to do, section 11.5. That will be in our next and last video. Until then, be well.